Let's talk now about how do we interact our fabric with external networks. We need this interaction because most of the servers that we are going to use exist or are connected in an external network. They are not living within the fabric. Remember that the I server, for instance, lives in a shared services block or in an on-premise data center. The Catalyst centered devices or servers are connected into a shared services block or into on-premise data center. The control plane nodes, the wireless LAN controllers are also installed in a shared services block or in a on-premise data center, and all my servers that I need in order to work with an enterprise network, such as a DNS server or my DHCP servers and many other servers, exist or are connected in the shared services block or in an on-premise data center. So all these servers are living outside the fabric. So I will need to communicate with devices that are living outside the fabric in order to have my enterprise network working. By default, if I don't set up any user virtual network, my fabric can communicate with outside networks because my fabric at that point in time is only consisting of a global routing table that exists in the underlay. And by default, the fabric creates some virtual networks, for instance, the infra virtual network, but this particular virtual network maps to the global routing table within my fabric. So at that moment, without having any users at all set up in my fabric, everything works because I am communicating an external global routing table with my fabric global routing table. So in that sense, the Catalyst Center can reach my devices, the I server can reach my devices, the access points can reach the wireless LAN controllers, my devices can reach the control plane nodes, and so on. So far so good. But what happens if I start adding users to my fabric? In that case, I will have devices that will be assigned IP addresses that live within a virtual network. And for instance, if this device wants to communicate with the DNS server, we have a problem because the DNS server, my DNS server, lives in the global routing table. And this device IP address lives inside a virtual network. So there is no way to communicate packets from devices that exist inside a virtual network that is actually a VRF to devices that live in the global routing table. They live in separate domains, in separate universes. So there is no way that this device that lives in this virtual network is able to query the DNS server because the DNS server lives in the global routing table. So here is where the fusion routers kick in. The fusion routers, in this case this fusion router, are the devices that will be in charge of landing the prefixes that exist in these virtual networks into the external global routing table. So in that way, then this device will be able to query my DNS server even though the DNS server exists in the global routing table. So that is the reason why I need a fusion router. The problem becomes more complex as I start adding virtual networks into my fabric, because now this fusion routers has to map these prefixes that exist in this blue VRF into my green global routing table, and it should also be able to inject the prefixes that exist in this orange virtual network into the green global routing table domain. You must take care when assigning IP addresses within your virtual networks, and do not repeat IP addresses. It is perfectly possible to repeat IP addresses in different virtual networks because they belong to separate routing domains, and you can repeat IP address, but you should not. So the best way to assign IP addresses, for instance, is use the prefix 10.100.0.0.16 to the blue domain, and 10.101.0.0/16 to the orange domain. So when this fusion router leaks these prefixes into the global routing table, these prefixes can be perfectly identifiable. So when we leak these prefixes into the global routing table here, I know for a fact that this 10.100.0.0/16 belongs to the blue virtual network, and this 10.101.0.0/16 belongs to the orange domain or virtual network. So when connecting our fabric through a border node to an external routing device, we can come across two possibilities. That this device is a VRF aware, so it will be able to create VRFs. So that is a good thing, because then we will be able to match virtual networks to VRFs. Or you can come across the case where this particular device is non-VRF aware. So if it is a non-VRF aware device, then you will not be able to create VRFs in this device, because it is unable to know what VRFs are, probably because it is a firewall or because it is an old device. So we will not be able to match virtual networks to VRF. So let's go to the first option. What happens if I am connecting my border node to a device that is VRF aware? So in this case, we're going to use, for instance, BGP and .1Q for doing this magic. We are going to create VRFs in this router that is VRF aware, and we are going to inject these prefixes coming from virtual networks into VRFs, and then we're going to do route leaking in order to let my external servers to be able to communicate with both routing domains. So this is the easier way to do it. One way of doing it is, for instance, if this is a router, I am going to create subinterfaces, and I'm going to create one subinterface per virtual network, or one subinterface for VRF, whatever you want to call it. So within the fabric, I have these two virtual networks. In the fusion router, I am going to create two VRFs. This VRF will match this corpo virtual network, and this VRF will match this company B virtual network ID. Then I will create the subinterfaces. This subinterface is mapped into the corpo VRF, and I'm going to create a BGP peering using that addressing, and this other subinterface is going to match the company B VRF, and I'm going to create a different BGP peering with this other subinterface. So I'm going to create several peerings, then at that moment in time, through BGP, through these different BGP peerings, I'm going to be able to inject all the prefixes that belong to the BNI corpo into the VRF corpo, and all the prefixes that belong to the BNI company B into the VRF company B. After doing that, the fusion router will have to do route leaking in order to let the prefixes that live in VRF corpo leak into the global routing table, and let the prefixes that live in the VRF company B be leaked into the global routing table as well. So the DNS server that lives here in this global routing domain will be able to talk with devices in different virtual network IDs. We're going to use prefix lists and maps and imports in order to do that. The configuration is mostly the same if I am not if I were not using a router but a layer 3 switch. Remember that in layer 3 switches I cannot use subinterfaces, but I can receive everything through a trunk. Then I'm going to use a switched virtual interface to achieve the same trick. I'm going to create the VRFs, and then I'm going to map one VRF to the corresponding switched virtual interface, and then I'm going to create a BGP peering for every virtual VRF that I'm going to create. So the configuration is mostly the same as the routers. The only difference is that I'm going to use SBIs rather than subinterfaces. So in summary, the Fusion router will provide access to shared services for the endpoints in my fabric. So for instance, I can have a virtual network with a device that now will be able to talk with, for instance, my DNS server, even though the DNS server lives in the global routing table and this device lives in a virtual network. I'm going to need the Fusion router in order to do that. Remember that it will first map these VNIDs into VRFs, and then it is going to do route leaking into the global routing table. The Fusion router must be manually configured. Now, what was the second scenario that I can face? I can connect my border node to a device that is non-VRF aware. So this router cannot create VRFs, probably because it is actually a firewall, or because it is an old router that cannot create VRFs, or it doesn't have enough licensing in order to create VRFs. Then when that happens, we're going to just create our BGP peerings, and we are going to receive the prefixes coming from the different VNIs, and we are going to make them land directly into the global routing table. So this seems a little bit easier, but it has a drawback, because given this router is practically VRF blind, then malicious traffic can come from this BNID, use this router as a default gateway, for instance, or as a gateway between both VNIs, and then it is perfectly possible to send traffic between VNIs and breaking my security here. So in order to solve that, I'm going to have to create these static routes at the border nodes in order to avoid traffic being able to come from one BNI and land into a different BNID. So I need to avoid this, and I'm going to set up these static routes here in order to avoid that. So for instance, if someone within this BNI wants to send traffic to the other BNI, so all traffic destined to 10.1.0.0 will be dropped here, because I'm going to create this particular static routes. And in order to avoid traffic coming from corporate, in order to land in the company B, I'm going to create this other static route. So I'm going to drop that traffic here at the border node. That's it.